So, well, basically, in this presentation, I'm going to show how we use the async API specification to detect anomalies in some platforms, smart ports platforms, that it's the use case in a European project we have, that it's the iDoArt project. This is something that is done together with ProDevelop, that it's a company in Spain. So, well, this is a work that started a long time ago. In 2020, we created an initial implementation of this toolkit that is based on MDE that was done in the Megamart project. And in this project in Megamart, we had a problem that basically we had developers that were developing some IoT platform based on some documentation, but the problem was that the documentation not always was reflecting what was the real needs of the company, especially in terms of the messages. So this is an IoT platform that uses MQTT to send messages, and there were a lot of consistency problems. There were deviations in the topics that can cause a loss of messages, and also in the message format that can cause information loss and runtime problems. So we thought what we could do to solve this, and we found the async API specification that it's designed to be able to describe the messages and the infrastructure of event-driven architectures. So basically, we did what we are all used to implement. Basically, based on the specification, we created a grammar, we obtained the meta model, and we defined a set of code generator templates to generate an internal DSL in Java. Basically, what we do, it's based on the specification, we are able to generate the documentation, and we are able to generate code. As I said, we can generate code. So if we want to create a message like this one in JSON and we want to send it using MQTT, using the specification, we can generate this internal DSL that allows us to create messages in this way. First, we create a builder, and we start to define the different properties of the message using, as I said, this internal DSL that enforces that messages are created in a correct way and that respect the data types and the structure of the messages we want to send. So basically, this is an example of how to use this DSL, finally to set up the different parameters and to send the message. Okay, this is something that it's we have been doing in the MDB community for a long time ago. This was published in several papers. We also have a repository with all the tool and the source code. Everything is open source. And in 2021, we started the iDoArt project. And in this project, it's a very big project that started in 2021. It's finishing this in fall of this year. It has a total cost of nearly 25 million euros with 7.5 million of European Union funding, and also similar funding from the different countries, also around 7 million. We are 34 partners, and we have lots of use cases. One of these use cases is this one I talked to you about, the smart ports platform. And during this period, what we have done is to contribute an extension to the async API specification for defining quality of service in these asynchronous architectures. We have published a paper. In fact, this was presented a few weeks ago in the Symposium of Applied Computing that it took place here in Spain, in Avila. And here we presented a meta model for this extension for async API. We also presented in a Spanish conference a UML profile to describe this kind of architectures. This was, since this was simply a UML profile, didn't have the impact that it's expected for a research publication nowadays in the MDE community. So this is why we simply publish it in a small conference here in Spain. And basically, as I said, this is a use case of this project that it's done in the together with ProDevelop, that it's a company that develops software for managing the operations inside the ports of several ports especially in Europe and also in Africa and some in Asia and America. Basically, they have a small port monitoring platform that is able to track all the operations that take place in the terminal of the different ports, and they have to analyze data and to process data in nearly real time. So basically, in this use case, it's very important that the messages are syntactically correct and especially that are timely delivered, because there are decisions that must be taken, as I said, nearly in real time. So they have a requirement on when to receive messages, on what kind of information they have to receive. So I'm going to show you the tool. It's implemented in Eclipse. It's no. Yeah. I don't know if it's too small, but basically here I have the project, and here I have the model. We started with a UML model as a starting point. Applying this profile, we define it for the Industry 4.0, and this was an initial implementation of the messages and of the infrastructure they have in some ports. So basically, we have observations that can be observations about the quality of the air, the humidity, the noise, the Wi-Fi points we have in the facilities. We also can define which are the different brokers of the architecture, and we also define which are the topics where these messages are sent. So, for example, if we check the topic of the Wi-Fi signal, we see that this topic it's under the prode/APV Wi-Fi name. We publish, and we have the publish and subscribe operations, and we specify that this topic publishes or messages of that follow the format of the Wi-Fi message, and the same for the subscription. Based on this model, we are able to generate an async API specification automatically. And based on this specification, here we have the model, and here we have which are the servers we have in the architecture. We have the different channels with the links to the different messages. And here are the different messages, and here are the specification of the payloads of these messages. Based on this specification, we can generate all this code we have here for the messages, for the schemas, the different channels, the publication and subscription operations, and here we have all the classes that implement this internal DSL that I presented before. And now now this is complaining because this is expecting the monitoring part, but if I remove this, it should compile. Here we have one example of a program that using the channels and operations can subscribe and notify when a specific message is received. And here we have the part of the program that sends messages in the Wi-Fi operation to notify information about Wi-Fi stations that are located in Valencia in Spain, and with different identifiers, identifier 1, identifier 2, etc. Well, this is something that was presented a long time ago, and now the part that we added for this use case was the monitoring part. So basically, based on this specification that, as I said, we can generate the code to send and receive messages, we can specify, for example, that one specific server can be monitored, since this is an extension that we have created that is not following the async API specification. We prefix all the new properties with an X. So we specify that this server, that the provision server can be monitored, and this forces that when we create an instance of the server, we must specify which is the server that we are going to use to monitor this server. This is because there are some quality of service properties that can be monitored directly by connecting to the topics and by watching which are the messages that we send on this channel. But there are some other quality of service properties that need to be that require some kind of orchestration and modification of the code that is being generated, so that the code to send and receive messages notifies every time a new event happens, and these events are sent in this monitoring server. In this case, for the demo, I'm using the same server in localhost for the monitoring and for the actual architecture, but this can be a different server. So now, as I said, we have these two servers, the monitoring server and the server, and this is the code that if we run this main method, we can see that the messages are being sent by this code, and this part here with the print statements is notifying every time a new message is received. As I said, this is the code that we were already generating some time ago. Now, if we want to monitor some quality of service properties, we here, let me check if it's irrigation is closing. I think it's a bit. We can define a new part for the quality of service metrics. And here, for example, we can define a Wi-Fi quality of service that it's, for example, we want to ensure that let's say, the period in seconds. This is something that I must define. So we are going to measure the period of the Wi-Fi messages in seconds, because we want to ensure that we receive a message about the status of the Wi-Fi stations every, let's say, 10 seconds. So first we define that we have this quality of service metric, and next we define the service level agreement specifications. So we are going to define the warranty terms is the Wi-Fi service level objective. This is going to apply to the Wi-Fi scope, for example, and that it's this topic of prod/Wi-Fi. So we have defined this scope, and the service level objectives. It's are, for example, as I said, we want to ensure that we receive one message every, let's say, 10 seconds. So we can define a range. So, for example, we want to define the quality of service metric. It's a metric type. No, I'm not going. I'm going to reference the one we defined above, that it's this Wi-Fi quality of service. The operator, for example, we want to specify that must be above 9. And the same we specify that we want to receive the period must be below 11 seconds. This is because, of course, we cannot ensure that it's going to be exactly 10 seconds. So we define that if we receive a message every between 9 and 11 seconds would be okay. So if we save this, automatically we also get all the monitoring code. Here we have the metrics, the Wi-Fi periodic metric, the different measurement instruments. For example, here we have the period instrument. We also can measure the latency. We have not implemented all the metrics because these were the two that were of importance for this use case. And here we have the expression and the different events that we are going to monitor. So everything, all the code to ensure that this quality of service metrics is are met, it's generated. And basically here we have the code for the monitor that basically what we do is to create the servers, we instantiate the monitor, and we start the monitor. So if we start the monitor code to show it this. Okay, this is I'm going to pin this console. And if we start the code we already had before, okay, here we have that we are sending the different messages, and now we have the login messages of the monitor that it's saying, for example, at the beginning, this takes some time to stabilize because we must track the initial point we are starting to measure. So we have the initial time we can define in Java. So until it stabilizes, for example, here we have that the period we sent a message in 1 second. So we have that here are the different conditions. And here we are seeing that the different warranty terms are met or not regarding the messages that are being sent. Okay. So basically, this is all. Well, as I said, we also can notify all the events that happen in the infrastructure. Here we have one subscriber that shows all the messages. So here we see that we are notifying where a client is connected, when it is subscribed, when it is connected, when a message is sent, when it's received, the different messages that are being sent, and etc. So this is all the stuff that we are running in this example. And basically, this was fast, but this is basically all of our prototype. Basically, from this profiled UML model, we can generate a async API specification that has several hundred lines of non-trivial code. And from this specification, we can generate several thousands lines of code that are not trivial. And this includes the boilerplate code for creating, sending, and receiving and consuming the messages, and the code to monitor how this architecture it behaves to ensure that the service level agreement specifications are met. And basically, this is all. As I said, here you have the tool that it's published in GitHub. It's open source. Yesterday, I noticed that the latest changes are not published yet. I will publish a new release by the end of this week. I published the version 0.9 with these latest changes, and I think that this is all. If you have any questions, please, you are welcome.